Welcome to this session. This session, we are going to discuss a problem on how to apply Newton's second law of motion to a problem involving a sky. So the problem reads, a sky of mass 65 kilograms glides down a slope at an angle of 32 degrees, as shown in this diagram. So find the sky's acceleration, that's the first part. And then number two, find the force on the snow that exerts on the sky if the snow is so slippery and that we can neglect the action of friction forces. Now, when we have such a problem, to be able to solve it, we need to draw a free body diagram and then draw an appropriate axis that can help us to resolve all the forces acting on the object. So we'll take the sky as an object, or we model the sky as an object, and then draw appropriate free body diagram to illustrate all the forces acting on the sky. In this case, there are two forces: normal reaction force on the sky and the weight of the sky. So we will draw an axis. So solution. We treat the sky as an object or a particle. Then identify all the forces acting. And in this case, there are only two forces, which is force of the weight of the sky and the reaction force on the sky. And then resolve the forces by drawing an appropriate free body, by drawing an appropriate axis. So this is what you'll do. So because we take this sky as an object, so we can take this as our y-axis, where we have the normal reaction. And then this we take as our x-axis. So next time this is the y-axis. So the x-axis and y-axis are meeting 90 degrees. And then this is how the weight of the sky will be acting. So from this point, so this is where the weight, which is given by mass times the gravitational acceleration. And then this, if you extend this angle of 32 degrees, is the same as this angle here. So what we do, we draw a triangle. So where this is 90 degrees, and this is how the forces are acting. So we'll have this the direction, and then this the direction. So this triangle here, if I call this point O, I call this point A, I call this point B. So I can illustrate. So this way you have the point A, call this one O, call this one B. So the direction is OA, and then AB. Remember, the length of OB is this weight of the Skyer. And then the angle theta is at point O. So this way you have the theta, which is the same as 32 degrees. So using Oshachota, so sine of the angle theta is opposite of hypotenuse. Opposite with respect to this is AB. Hypotenuse, the length of this hypotenuse, OB, is the weight W. So that means that AB will be given by W sine theta. So therefore, AB, this opposite side, this is W sine theta. So W sine theta. And then cosine from Oshachota is given by adjacent of hypotenuse. So cosine of the angle theta, adjacent is OA, hypotenuse is W. So it means that OA is W cosine of theta. So this is W cosine of theta. And then, so we call this one W cosine of theta. And remember, theta remains to be 32. So then now we resolve forces, upward forces and downward, we resolve forces in the Y direction and the forces in the X direction. So we know by definition, net force, summation, so net force is given by the forces in the X direction plus forces in the Y direction. So let's say forces in the X direction will be given by, now in this diagram, this is the only forces acting in the X direction. So we'll have, and by definition, net force is given by mass times acceleration. It's given by M AX to mean acceleration in the X direction. So since this is the only force acting in the X direction, so we'll have W sine theta should give us mass times the acceleration in the X direction. So weight is mass times gravitational acceleration times sine of theta should give us mass times acceleration. And you see, if we divide through by mass, so it implies that acceleration is given by G sine theta. So G is 9.8 and then sine of 32. So let's work out that. So 9.8 times sine of 32 gives us 5.193208789 meters per square seconds. So that is the acceleration of the Skyer, because the Skyer is moving in this direction, X direction, according to this axis. Now, resolving components in the Y direction. So summation of forces acting in the vertical direction is given by this formula. And since this object is not moving in the vertical plane, then the acceleration in the vertical plane is 0. So this means since no vertical motion, the Skyer it implies that acceleration in the vertical direction is 0. So the formula will be summation Fy on net force in the vertical direction is given by 0, because this value will be 0. Now, forces acting in the vertical direction. So we take forces acting in the y direction. We take forces moving upwards to be positive, and then forces moving downwards to be negative. So we'll have this reaction be taken to be positive, and then this force, this is the direction here, is taken to be negative. So we'll have the normal reaction minus W cos of theta should give us 0. So which means that R is given by W cos of theta, which is mg cosine of theta, and mass of this kaya is given by 65, G is 9.8, and angle is 32 degrees. So 65 times 9.8 times cosine of 32 gives us 540.2066373 newtons. So therefore, the force, there's no exerts in the sky. Is approximately 540.2 newtons. This to nearest 4 significant figures. So that's how we solve that problem. Thank you.